Hello everyone and welcome to the YouTube channel of BeingACCA. This is Tushita Gupta, ACCA affiliate, and in this video we are continuing with our PM pre-June mock exam. So this is the third OT case study, the last one for your section B. This is the name of the company is Solar Company. So as you can see through the first requirement itself, overhead absorption per unit. So I can ascertain that it is about the overheads unit where we have done, learned about different absorption techniques. So specialized cost accounting techniques, you can say. So this is the entire case study basis which we have to answer questions 26 to 30. So let us read the scenario once. Solar Company produces a range of solar-based household lighting systems such as ceiling light, garden light, table lamp, and others. With the advanced manufacturing technology used, some of the simpler products were produced from a few sharing production lines, while other products with more sophisticated electrical components were produced from another set of production lines. For product valuation and pricing purpose, the company adopts a cost plus pricing approach with 20% markup on production cost. So they are marking 20% up as a profit on their production cost. As for the system of production overhead absorption, a traditional single factor model based on machine hours have been in use. However, as a preparation to apply ABC system for overheads absorption, the budgeted information of the company for the coming quarter that fit ABC system are as follows. So you have the cost pools, you have the cost drivers. The above budget has included estimated activities required for a quotation required by a small company to supply two models of garden lights, model X and Y. So out of these 200,000 machine hours that we have in total, this order is also something which is included in this. So the estimated activity levels of the quotation are given below, X and Y. These are the number of machine hours that they're going to be taking, setups, number of parts to be handled. Based on the existing overhead absorption system in use, the proposed price to be quoted, including the prime cost for model X and Y, is given to you as $80 and 68.4 per unit respectively. All right, so this was our case study. Now let us move to the very first requirement that is there with this question. So the first thing that this asks you is based on the existing system, which option shows the overhead absorbed per unit of model X and Y. So over here, you have to find out the overhead absorption for model X and Y, and you need to select whichever option is giving you the correct cost for both of them. So let us work it out individually. Firstly, I need to find out how much per hour are we charging. So the present system, like it told you, a traditional single factor model based on the machine hours have been in use. So to first find out my overhead absorption rate, it's nothing but the total cost which is there, 1480000 divided by your total number of hours which are being used, which is 200,000 machine hours. So this 7.4 is worked out as my overhead absorption rate. Now the next thing that I need to do is find out how many hours is each unit of X and Y taking, and then if I multiply the overhead absorption rate, I will have the overhead absorbed per unit. So firstly for X and then for Y. So for X, I will be producing 5,000 units and I will take 35,000 machine hours. That means per unit, I am taking 7 hours. 7 hours is being taken per unit of X and 20,000 divided by 4,000. That means 5 hours are being taken per unit of product Y. So the absorption rates are going to be simple, just the number of hours that they take multiplied by the cost that we absorb per hour. So this multiplied by this figure over here. So 51.8 and 37, this is what we get in option 4. So we select this one over here. Moving ahead to the next question, based on ABC system, which option shows the overhead absorbed per unit of model X and Y? So now we have to base our calculations on the ABC system. So these are all of the cost pools along with the cost drivers, and then below we have the information regarding how much of what is X and Y using. So first, let us find out the cost per, a cost according to the driver. So I can, just for the purpose so that I can illustrate you how we solve this, I'm first putting in the cost pool, then I'm putting the cost driver rate. So basically it's going to be the rate at which we adjust for the cost. So firstly, if you take the setup cost, let me insert a row over here, a column, yes. So the first thing that I have is my setup. And for the setup, basically the total cost that I'm incurring is 320. And the rate, basically this is going to be divided per setup. It's going to cost me this value over here divided by 40, which is the total number of setups which are there. So that means every setup is costing me $8,000. Similarly, I will do it for rest of the costs also. Component handling, this in total is costing me 300,000. So my driver rate is going to be this divided by the number of parts which are handled, which is 100,000. So that gives me 3. Then for the production, so my production is 550,000. And the total number of machine hours are 550. You can take this figure from here divided by 200,000. So this is my rate. And then for the finished goods, I have 400,000. This needs to be spread across 50,000 units which are produced in total. So divided by 50,000. So with this, these are my cost drivers rate which I basically have. Now let us see for X and for Y. We over here have to find out the per unit. So we'll work in per unit terms. This is for model X and this is for model Y. Let us scroll down to the information where we see how much are they using of what. So if you see for setups, for product X, it's going to take 4 setups in total. This is the cost per setup multiplied by 4 gives you the total setup cost. Now, if you want to find it out per unit, you will need to do the, divide by the number of units and you will have your answer in per unit terms also. So let us keep working towards the other things as well. Now, if I constantly do it for the Y also, this is the driver multiplied by 6. Similarly, for component handling, parts handled, so per part it is $3 and with product X I'm handling 6,000. Over here again per unit is same, then I'm handling 9,000. For the next one, machine hours 2.75 per hour and 35,000 is the number of hours that I'm using. 2.75 multiplied by 20,000. And then last but not the least, I have the finished goods handling, which is dependent upon the number of units. So number of units is 8 per unit is the cost multiplied by 5,000 over here. And then 4,000 multiplied by 8 over here. So with this, we have arrived at the the cost which we have allocated between the model X and Y. Now these are the total. If you sum all of this up, you're going to have the total. You can copy this to the other cell as well. So with this, these are the total costs. Now, if you just divide this by the number of units that we are going to be producing, units that we are producing is 5,000 and 4,000 respectively. So if you just divide the total allocated by the number of units, you will have the per unit cost. So for this model X, you're getting 37.25 and for model Y, you're getting 40.5. Let's see which option gives you this. I think it is option 2 over here. So we select that and we move ahead to the next question. Select whether each of the following statements pertaining to the price quoted for model X and Y are correct or incorrect. So the first statement tells you the price quoted for both model X and Y are likely to affect the markup achieved as compared to the target of 20%. So if you see the cost which has been quoted over here, it is 80 and 68. And what we have found out is that the apportioned cost is, this proportion over here. So if you see, are we given with the total cost? Including prime cost. So we are given with the selling price. So we have the selling price given to us as 80.4 and then 68.4. So basis that if I see, if I just apply a 20% markup on just my overhead simply, how much is my markup going to be? Markup is going to be, if I just multiply this by 1.2 so that I see how much am I basically getting. So if you see over here, a majority chunk of your, so over here, the price quoted for both model X and Y are likely to affect the markup achieved as compared to the target. Definitely yes, because if you see, we are not including the prime cost over here, just applying a 20% markup on simply your overheads, you're getting these high figures. So definitely, this is going to affect the target markup, which you have thought to be 20%. Then the price quoted for model X are likely to be underpriced, whereas model Y are likely to be overpriced. This is absolutely incorrect. And why is that? Because the model X per unit, if you see, it's basically lower using the ABC costing, because even though the number of units are high over here, it is using lesser of your, if you divide it according to the cost drivers, it is using lesser of your resources, the drivers which are being utilized. So over here, ABC, with using ABC, you're getting a lower per unit cost for model X. Hence, this statement is incorrect. Let us move to the next question. This is the second last one. The prime cost per unit is given to be this much and this much. Based on the price which has been quoted, what is the revised markup for both X and Y when adopting ABC? So let us see how much markup are we getting if we use this as our prime cost. So let us do our calculations. This is the price that we have quoted. This is our selling price. So the selling prices are right in front of us. Now, if we take our prime cost is given to be 15.2 and then 20 respectively. Then next thing I need are my overheads right over here. These were the overheads which we had calculated. All right. Now, the next thing that I find out is my, gross profit. So my gross profit is nothing but selling price minus this. So I get this as my gross profit. Drag it to here as well. Now, if you see the revised markup is always based on cost. So over here, if I need to find out how much my markup over here is. So my markup will be nothing but this value over here divided by how much I have found out to be the total cost. So let me total up the cost in one place. Total cost is nothing but prime cost plus your overheads. So this is what your total cost looks like. So your markup is nothing but your gross profit divided by the total cost. So with this, you get 53.29% and then 13.05 or roughly 0.6 is what you get over here. So I think it's option 1 that could be our potential answer. All right. Now moving to the very last question, which of the following statements is not true about the adoption of ABC system? So we have to select which is not true over here. So ABC system will not improve the accuracy of the product cost information regardless of the complexity of the production process. This is definitely true because, when basically this statement is saying that it will not improve the accuracy of cost information. This becomes your answer over here because this is in fact true. Sorry, this is not true, and you have to choose the option which is not true. This becomes a little bit confusing over here because you have to select something which is false, and this statement is also false over here. So this is your answer. Now let us see why these are all are true. ABC system is more suitable for highly automated manufacturing environment as compared to labor intensive. This is absolutely correct. ABC system may require a significant change in the design of the information. Yes, that's true, because how they collect information, now they're going to have to make detailed information available for using ABC. So this is also not true. Moving to the very last statement, ABC may lead to improvement in profitability and market competitiveness. This is not true. Hence, this is not your answer. With this, we have come to an end to this question. I hope that this was useful, and I'll see you in the next one.